Graphing decay. So basically, graphing decay functions is pretty much the same thing as graphing growth, except that the graph is going to start high, then it's going to go into the asymptote. Okay, so everything that I looked at with graphing growth, we can basically apply here. We should start with the translations. The -5 is going to shift everything down 5 units, which is going to put us way down here. That's going to be your horizontal asymptote. The +3 is going to shift everything to the left 3. And we're going to think about this as the origin as we plot what we think would be this, 1/2 to the x power. Okay, so again, when x is 0, you're going to get back 1. So we get a point here. When x is 1, you're going to get back 1/2. When x is 2, you get back 1/4. Moving in the other direction, if you use -1, you're going to get back 2. It's going to cause that reciprocal. -2 is going to be the reciprocal of 1/4, which would be at 4. And we can probably get one more in. -3 is going to be the reciprocal of 1/8, which is going to be 8. So we got 2, 4, 6, 8. And that's your graph. Much like the growth functions, the domain is going to be all real numbers. The range is going to be bounded below at -5 and goes up to infinity. For example 2, we have another decay function. It's a little bit disguised here using the 0.25 as the base, but that is the same thing as 1/4. In fact, as we do the problem, we should probably just interpret that as 1/4 because it'll make the reciprocals a bit easier. But like any of the previous problems, what we're going to do is start with our translations. This does have a horizontal translation, 2 units to the right. It does not have a vertical translation. There's no constant at the end here, which means that the horizontal asymptote is still going to be located here. And we're going to think about this function. Again, I'll change that to a 1/4. We're going to think about that and pretend that this would be the origin as we plot points. Okay, so when x is 0, you're going to get 1 here, but then 1 times 4 is 4. So we're going to have to go up 4 units, which will plot a point there. When x is 1, you're going to have 1/4 times 4, which is going to give you 1. So we get a point here. When x is 2, we're going to get 1/16. We'll have 4 times 1/16, which is the same thing as 4/16, which becomes 1/4. So we get a point there. Moving backwards, I don't think we're going to get much. If we use a -1, we're going to take the reciprocal of this, which is going to give you a 4, and then 4 times 4 is 16. Okay, so if I went over here, I'd have to go up 16 units, okay, which is going to be well off of our graph. So I think this is about everything we're going to get. But still good enough to get a nice picture. Okay, the domain. It's going to be all real numbers. The range is going to be bounded below at 0. All right, and for example 3, we finally have something a little bit different. What I want to do is write a function that fits this template. Go ahead and notice that we don't have an h value in there. Okay, but I want to write something that's going to fit that template, given the provided information that the range is -1 to infinity, and it also contains these 2 points. Okay, so here's our template again. We've got f of x is equal to a times b to the x. We don't have an h. There's no horizontal shift here, plus k. Okay? The first clue that I'm going to use is the one that's right above it here. Okay, the range is going to go from -1 up to infinity. Okay, that tells us 2 things actually. One, the fact that it goes up forever means that our a value is going to be positive. That can't be negative. 2, it's bounded at -1, which means that this whole graph has been shifted down 1 unit. In other words, that is k. That's your k value. So we've got f of x is equal to a times b to the x minus 1. We've got that much figured out so far. Okay, let's go ahead and take this coordinate next because it has a 0 in it. Okay, more importantly, it has an x of a 0. So that tends to cancel certain things out. Okay, let's go ahead and plug that in and see what we can learn from it. Okay, the 3 is going to be the output. So we're going to say 3 equals. We've got a times b. What we're going to be doing is plugging in the 0 for the x. So that goes here, and we've already got the minus 1. Okay, now b to the 0 power is just going to be 1. Okay, keep that in mind. So let's go ahead and move this negative 1 over, though. We get 4 is equal to a times 1, which means that a is equal to 4. Okay, let's take our last coordinate. The output is 8. We've figured out our a value to be 4. What we don't have is the b value. But if we raise it to the second power and work all of this out, it should become an 8. Okay, so let's move things over again. We're going to go ahead and add that on, which is going to give you 9 is equal to 4 times b to the negative 2. We'll go ahead and divide by 4. And a lot of this becomes a logic game now. This exponent, because it's a negative, causes a reciprocal. At the same time, things are being squared. So what I want to do is undo the reciprocal, which means just take the reciprocal again, but then undo the squaring as a square root. So what I want to do is take the square root of 4 over 9. That'll be our b value, which is going to equal 2/3. So overall, f of x is going to be equal to 4, that would be your a value, times 2/3, that'd be your b value, to the x power minus 1.
Wait, what?